When calculating the per unit impedance of a cable, the base voltage is a crucial parameter. The selection of the appropriate base voltage ensures accurate and meaningful per unit values, which are essential for various power system studies and calculations. In this specific scenario, a 500 mcm 1 kV Tech90 cable is connected to a 600 volt system. Therefore, the base voltage for calculating the per unit impedance of the cable should be 600 volts. The reason for this choice is that the per unit system normalizes values with respect to a chosen base. The base voltage represents the nominal or operating voltage of the system to which the cable is connected. Using the system voltage as the base allows for a direct comparison of the cable's impedance against the system's voltage level. If you were to use the cable's voltage rating, which is 1 kV in this case, as the base voltage, the resulting per unit impedance would not accurately reflect the cable's performance within the 600 volt system. This is because the per unit value would be normalized to a higher voltage level than the system's actual operating voltage. The per unit impedance is calculated by dividing the actual impedance of the cable by the base impedance. The base impedance is derived from the base voltage and the base power. Given that the base voltage is 600 volts, the base impedance can be determined using the formula base impedance equals base voltage squared divided by base power. For example, if the base power is 100 kVA, then the base impedance would be 600 volts squared divided by 100 kVA, which equals 3.6 ohms. Then the per unit impedance would be calculated based on the actual impedance of the cable divided by this 3.6 ohms. Firstly, determine the actual impedance of the cable. This involves obtaining the cable's resistance and reactance values, typically expressed in ohms per unit length, such as ohms per kilometer or ohms per mile. These values are usually provided by the cable manufacturer and are specific to the cable's construction, material, and operating frequency. Secondly, determine the base impedance. Select the base power that is relevant to the system being analyzed. It is vital to choose a base power that is commonly used and appropriate for the voltage level and scale of the system. Common base power values include 100 kV and 1 MV. Thirdly, calculate the per unit impedance. Once you have the actual impedance of the cable and the base impedance, you can calculate the per unit impedance by dividing the actual impedance by the base impedance. The resulting per unit impedance is a dimensionless value that represents the cable's impedance relative to the chosen base. The per unit system simplifies calculations and allows for easier comparison of different components within a power system. By normalizing values to a common base, it becomes easier to identify potential issues such as voltage drops, fault currents, and system stability. It also allows for easier scaling of results to different voltage and power levels. In addition to the base voltage and base power, it is also important to consider the cable's operating temperature when calculating the per unit impedance. The cable's resistance increases with temperature, which affects its overall impedance. Cable manufacturers typically provide temperature correction factors that can be used to adjust the resistance values for different operating temperatures. These correction factors should be applied to ensure accurate impedance calculations. Moreover, it is vital to consult relevant standards and guidelines when determining the appropriate base voltage and calculating the per unit impedance. Standards such as the IEEE standards provide detailed recommendations and best practices for power system calculations, including per unit analysis. Adhering to these standards ensures that the calculations are performed correctly and consistently. To reiterate, when working with a 500 mcm 1 kV Tech90 cable connected to a 600 volt system, the appropriate base voltage for calculating the per unit impedance is 600 volts. This ensures that the per unit values accurately reflect the cable's performance within the actual operating conditions of the system. Using the cable's voltage rating as the base would lead to inaccurate results and potentially incorrect conclusions. Always remember to use the system voltage as the base voltage for per unit impedance calculations. This is a fundamental principle in power system analysis. Choosing the incorrect base voltage can lead to significant errors in your calculations, which can then result in flawed designs and incorrect operational decisions. To illustrate the importance of using the correct base voltage, consider the following example. Suppose the actual impedance of the 500 mcm cable is 0.1 ohms. If you use a base voltage of 600 volts and a base power of 100 kilovolt amps, the base impedance would be 3.6 ohms, as calculated earlier. The per unit impedance would then be 0.1 ohms divided by 3.6 ohms, which equals 0.278 per unit. However, if you mistakenly use the cable's voltage rating of 1 kilovolt as the base voltage, the base impedance would be 10 ohms, and the per unit impedance would be 0.1 per unit. This difference in per unit impedance values can have a significant impact on your calculations, especially when analyzing voltage drops or fault currents. The lower per unit impedance value obtained using the incorrect base voltage would underestimate the cable's impact on the system, potentially leading to incorrect conclusions about system performance. In addition to selecting the appropriate base voltage, it is also important to ensure that all other parameters used in the per unit calculations are accurate and consistent. This includes the cable's resistance, reactance, and operating temperature, as well as the system's voltage and power levels. Any errors in these parameters can also affect the accuracy of the per unit results. Furthermore, it is worth noting that the per unit system is not limited to impedance calculations. It can also be used to represent other electrical quantities such as voltage, current, and power. When working with per unit values for these quantities, it is important to use the same base voltage and base power as those used for the impedance calculations. This ensures consistency and allows for meaningful comparisons between different quantities. In summary, the base voltage for calculating the per unit impedance of a cable should always be the system voltage to which the cable is connected. Using the cable's voltage rating or any other arbitrary voltage as the base can lead to inaccurate results and potentially flawed designs. Always ensure that all parameters used in the per unit calculations are accurate and consistent, and consult relevant standards and guidelines for best practices. Remember, the per unit system is a powerful tool for power system analysis, but it must be used correctly to obtain accurate and meaningful results. By understanding the principles behind the per unit system and following the guidelines outlined above, you can ensure that your calculations are reliable and that your designs are sound. Understanding the purpose of the cable also contributes to the overall calculations. Is the cable being used for power distribution, connecting generators or transformers, or feeding critical loads? Its purpose affects the importance of precise calculations. In critical applications, precise calculations are very vital. Furthermore, consider the impact of harmonic distortion. Harmonics can significantly affect cable impedance, and it might be necessary to account for harmonic frequencies in the per unit calculations, especially in systems with nonlinear loads. Also consider the shielding and grounding of the cable. Proper shielding and grounding are vital for minimizing electromagnetic interference and ensuring safe operation. These factors should be considered in the overall system design and analysis, even though they do not directly affect the per unit impedance calculations. Be mindful of the limitations of the per unit system. While it is a powerful tool, it is based on certain assumptions and simplifications. It is important to understand these limitations and to use the per unit system appropriately. For example, the per unit system assumes that the system is balanced and that the voltage and current are sinusoidal. These assumptions may not always hold true in real-world systems, especially under fault conditions. Be aware of the potential for errors and to validate your results using other methods such as simulations or field measurements. Finally, remember that power system analysis is a complex field that requires a thorough understanding of electrical engineering principles, mathematical techniques, and industry standards. The per unit system is just one tool in the power system engineer's toolbox, and it should be used in conjunction with other tools and techniques to solve real-world problems. By continuing to learn and develop your skills, you can become a proficient power system engineer and contribute to the design and operation of reliable and efficient electrical systems. When you select the base voltage to be the system voltage to which the cable is connected, you are accurately representing the operational scenario. If the cable is connected to a 600 volts system, then the 600 volts base voltage is the correct choice. It is important to remember that the per unit system is a normalization technique, and it is designed to simplify calculations by expressing all quantities as a fraction of a chosen base value. The base value is usually the nominal or rated value of the quantity, but in some cases, it may be a different value that is more convenient for the specific application. In the case of impedance calculations, the base impedance is derived from the base voltage and the base power. The base voltage is the nominal voltage of the system, and the base power is a convenient value that is used to scale the impedance. The per unit impedance is then calculated by dividing the actual impedance by the base impedance. The per unit impedance is a dimensionless quantity that represents the impedance of the component relative to the base impedance. This allows for easy comparison of the impedance of different components in this system. When the cable is not directly connected to a 600 volt system, perhaps through a step-down transformer, then the calculations may need to change. In this case, the cable's per unit impedance is calculated by first converting all values to the same voltage base. This involves multiplying the cable's impedance by the square of the turns ratio of the transformer. The resulting per unit impedance is then expressed in terms of the system's voltage base. By following these steps, you can accurately calculate the per unit impedance of the cable and use it for various power system studies and calculations. Remember to always double-check your calculations and to consult relevant standards and guidelines for best practices. With careful attention to detail and a thorough understanding of the principles involved, you can ensure that your power system designs are safe, reliable, and efficient.